Okay, so this is a basic air handling unit. So the air handling unit, we have the air inlet, the air outlet. We are heating up the air with a heating coil. So in the heating coil, we have a water inlet with hot water, a water outlet with not as warm water, or I don't want to say cold water because it's not cold, it's warm, but it's the temperature here is higher than the temperature there. But we can have another option for air handling units. So imagine that we have the air handling unit with two coils. So this is the heating coil. And we can copy this and we can have here a cooling coil. Good. A cooling coil. So on the cooling coil, what we are doing here, we are the water inlet. In this case, it's cold water. And what are we doing here? We can release hot air or warm air through this cooling coil, and then the arrows would be different. That would be cool air, and that would be hot air. And this is a cooling coil. There you go. Usually in air handling units, we have both. If it's winter, we are using the heating coil. If it's summer, we are using the cooling coil. But we have both coils on the same air handling unit. So if it's this is the air handling unit working in a heating mode, so for winter, and that would be the air handling unit working in the cooling. So this heating coil is off, so it's not working, and let's say that it's not working. And now it will be the other way around. So imagine that here the hot air, it's at 90 Fahrenheit, and we want the air at 60 Fahrenheit. Okay, so here the air, the hot air goes through the heating coil. There is no water running through the coil, so nothing happens. And here on the cooling coil, the air cools down. Okay, so this is what we are doing here. So here we have 0.1. So we have calculated the enthalpy of 0.1, this one. Then we have calculated the enthalpy of 0.2, and we need the energy. So this is the energy that we are releasing with this heating coil. Okay, so we have this air temperature at the beginning, and at the end we have this air temperature. So we need energy. So this energy comes from the heating coil. This is what the air handling unit is. So we are ventilating because we are taking fresh air from outside. That if we had a window, we open the window, yeah, we have a fresh air inlet, but we can't control first the flow, the amount of air that is coming, and then we can't control the temperature. With air handling units, we can control the amount of airflow that we need, and then we can control the temperature. So it's a more effective way to ventilate the building. So this is what air handling units are. As I have told you, we are going to use air handling units in every single exercise in this course, because the only thing that is mandatory, or the only element that you have to use, is the air handling unit. Then you can use heat pumps, you can use boilers, you can use ground source heat pumps or split units, whatever. But if you are working with a commercial building or a big building, not a single family house, you are going to need air handling units. So that's why I'm insisting on these units, and I will insist, because this is what we are going to use every single week. There will be an exercise, and the air handling unit will be necessary to complete the exercise. There are more things in air handling unit. So this is the basic one. So the basic air handling unit, we only have a coil. This is something more advanced because we have two coils, a heating coil and a cooling coil. And we can have more things or air handling units. So if you look at this, yeah, so you see that there are a lot of things. We have filters, we have fans to move the air. We can have different pipes or different ducts, not just the inlet and the outlet. We can mix or we can recover part of that heat. So the air handling units are getting more complicated. The basic air handling unit is this, a box with a coil. This is the air handling unit. Those are comfort conditions, 70 Fahrenheit and 50% of relative humidity. Those indoor conditions are common. It depends on the use of the building as well. But it can be 70, 73, or 68, or the relative humidity, it can be 40 or 45 or 50. But around these values, we have comfort. Okay, and this is the outdoor condition. So in winter, we can have, let's say, 20 Fahrenheit, and in summer, we will have 90 or 95. Okay, so the goal of the air handling unit is provide the building with comfort conditions, and those are comfort conditions. So yeah, you were right. Okay.
Okay, thank you.
What else? Well, if you go to Canvas, I'm going to post 2 lessons. It's not there yet because I have to fix something, but I'm going to post, 2 videos. So if you open this, oh, good evening, Anna. Okay, so I have uploaded 2 videos here. They are not posted yet, but you have to watch these 2 videos on lesson 3 for heating systems. There are 2 videos because it was too long, and I have divided this in 2 because it was too much for. But you have to watch both of them, and then you have to complete this quiz. Okay, so we have a quiz on heating systems, and there are 5 questions. Okay, so by next Wednesday, no, by next Thursday, so the day after tomorrow, you have to watch the videos, and then you have to complete those quizzes. And what are we going to do today? We are going to explain. Yeah, please. So we'll post this PowerPoint as well, because this is something that students, last year students, they helped me prepare, and we came up with this PowerPoint. And I think it's interesting because here we have all devices that you might use in a building. Okay, so we have boilers, we have air handling units. This is a fan coil. These are heat pumps. This is the split indoor unit, the split outdoor unit. This is a gas furnace. This is a ground source heat pump. We have heat recoveries, PV panels, wood stoves, refrigeration towers, solar thermal panels, chillers, pellet stoves, radiant floors, chilled beams, and chilled ceilings. Okay, so I think if you know all these devices, you know 95% of the devices that you will use in all buildings that you might design from now until the end of your professional career. maybe there's something that I haven't included here, but I haven't included here because, well, this is the first course on systems and we can't explain everything 100%. But I think this is 95% of the systems that you are going to use. And then you will have time to learn more advanced systems, or maybe the systems that we think are the future, they are not. So we have to wait 10 or 20 years to see some systems that are now available in the market. It will be in the market for 10 years or maybe not. But those systems have been available for architects and engineers for 50 years. And we need to know what they are, and we need to know the differences between all of them. So we are going to explain this many times. So today, this is the first contact with all these. Well, you should know what a boiler is. You should know what an air handling unit is. There's a lesson on air handling units. You should know. And I'm opening this one. Assignments. No. Classwork. Okay. I'm opening the names, and then we will make an exercise with this. Okay, so this is something on the exams or in other assignments, I will give you something like that. I will give you different elements, and then you have to connect the elements in the right order, because yeah, we have here air. Here, this is an air-to-water heat pump. We have a buffer tank, which is this one. We have the expansion tank, which is the red thing here. And then there's a shower. This is the shower. And this is a circulating water pump. Okay, and this is a radiant floor. So we have these 1, 2, 3, 4, 5, 6 different elements, and then we have to connect those elements. And there is only one way to connect them. So we cannot connect these to the radiant floor or the expansion tank to whatever. Okay, so there's only one way to connect this. But first, we're going here. I have the names that I had on that table. We have radiators, heat pumps, air-to-water heat pumps, heat recoveries, air handling units, radiant floors, chilled beams, chilled ceilings, fan coils, boilers, all these. Okay, so this is a list of devices that we can find in a building. And now we're going to classify those devices, and we are connect different devices with other different devices. So the first classification that we can make is the energy production. Okay, make it. This is the energy production. We can have ventilation devices. So we will type here ventilation. And we can have terminal units. Okay. What is energy production? Those are devices that generate energy. Basically we burn fuel and then we generate energy. This is what most of these devices are doing, or they run on electricity. So to generate electricity, or we generate energy, we can either burn fuel or use electricity. Those are the only ways that we have to produce, or it's not to produce, it's to transform energy in buildings. We transform the energy that is embedded in gas or fuels. We burn those fuels and we generate thermal energy, and then we heat up or cool down water or air with this energy. Okay, but we have energy production systems, we have ventilation, and we have terminal units. The terminal unit is the unit that we see in the room where we are living. Usually we don't see energy production devices. Those are either on the roof or in mechanical rooms, but we are not in contact with this energy production device, but we are in contact with the terminal unit, because the terminal unit is within our room where we are living. Okay, so let's first let's try to select all the energy production devices that we have here. For example, a heat pump, an air-to-water heat pump, is an energy production device. So this is in that list. A heat recovery, it's something for ventilation. So we have heat recoveries. And air handling units are devices for ventilation. So with heat recovery and air handling unit, we are done with ventilation systems. Then radiators. The radiators are terminal units. A radiant floor, it's another terminal unit, because a radiant floor, we are not producing energy. Radiant floor, it's underneath the floor that it's in our room. Okay, but it's also a terminal unit. What about chilled beams and chilled ceilings? We haven't talked about this yet, but those are also terminal units. What about the furnace and stoves and boilers? That is clear. Those are energy production systems. We have a boiler, produces energy. We have a gas furnace. Boiler, it's a generic, we can have, all these are boilers, okay? We can have stoves or furnace, but those are boilers. Those are things that, devices that burn a fuel and then generate heat. So all these are energy production. We can burn wood, or we can burn pellets, or we can burn gas, or oil, or diesel, or gasoline, or whatever. But whenever we are burning something, it's a boiler, but then we can have specific boilers. What else? A fan coil. Okay, a fan coil is another terminal unit. A ground source heat pump, everything that is a heat pump, it's a production, it's energy production. Then this is interesting. We have the split, the outdoor unit, and we have the split, the indoor unit. The outdoor unit, it's always an energy production device, and the indoor unit is a terminal unit. Then a chiller. What is a chiller? It's a different way to, it's like an air-to-water heat pump or water-to-water heat pump. So sometimes we use heat pump, and sometimes we use chiller. The difference is that heat pump, we can heat up or cool down water with heat pumps. With chillers, we only can cool down water. So it's the name is chiller. Okay, so we only can chill water, or we can cool down water. We cannot heat up. But it's a device that runs on electricity. So it's like a heat pump that only works for cooling. This is a chiller. What is a refrigeration tower? Good question. We haven't explained these kind of towers yet, but this is another energy production device. And then we have solar thermal panels and PV panels. Those are not terminal units. Those are not for ventilation. So they are energy production devices. Okay, so there are like three big groups. We can, okay, so this is the first group, the ventilation. This is the second group, the terminal unit. And this is the third book, the energy production. I don't know if when you were kids, the first contact with mathematics that you had when you are 6 or 7 years old is working with these groups and connecting things. When I was a boy, a 6-year-old boy, I remember that I went to school and I had a teacher that started talking about this. And I hadn't found the utility of this of that lesson until today. So today, I think we're going to use this because now we have to group different devices. So we have 3 different groups, and now we have to connect them. Okay, how can we connect them? because now we need to understand what energy production unit or energy production device can supply energy to the terminal units. So let's do that. Let's do it. So the easiest thing is the split. If we have the split outdoor unit, and here we have the split indoor unit, we just can connect these two elements here. Okay. And that's the only relationship we can have here. So if we have an outdoor unit, split outdoor unit, we need a split indoor unit. We cannot connect these to radiators or radiant floors or whatever. So those are connected, and that's it. Other things are more complicated. For example, a boiler. Can we use boilers with radiators? What do you think?
Yes, question mark?
Yeah, the question is, can you use boilers with radiators?
Yes.
Yes. Okay. Anyone has a different opinion? No, I hope so. Okay, yes, boilers and radiators, because a boiler heats up water and a radiator uses hot water to release heat to the room. Okay. Another question, can we use boilers with radiant floors?
Yes.
Yes, we can. Can we use boilers with fan coils?
Yes.
Yeah, are you sure? Do you think, okay, we're using radiant floors and we're using fan coils. Okay, the question is, or so the answer is yes, we can use boilers with fan coils. What is a fan coil? A fan coil, it's a fan and a coil. We know what a fan is. Now we know what a coil is. So a fan coil, it's a device that has a fan and has a coil. Very straightforward. If we look up on the internet fan coils, this is a fan coil, but this can also be, because sometimes it's very different. It's very difficult to tell what a fan coil is and what an indoor split unit is, because we can have a split unit. Okay, we all know these kind of split units on walls, but we can also have this kind of split units. Okay, so this is a fan coil, and this is a split unit, an indoor split unit on the false ceiling. What's the difference? If you look at this, you can't tell, so it's impossible, because we have a grill here, and then we have all these, but it's the same. The difference is this one. If we have water pipes here, this is a fan coil. If we don't have water pipes, it's a split unit. Okay, so in this case, you see that we don't have four. Here we have 1, 2, 3, 4. So this is the hot water inlet and outlet, and the cold water inlet and outlet. If we have four pipes here, this is a fan coil. We don't have four pipes here, so this is not a fan coil. We have other pipes here, and we have other inlets or outlets, but it's not for water. Okay, so look at this. This is the indoor split unit, and this is a fan coil. It's the same. But all these fan coils have, forbidden. Why? All these fan coil units, they have 4 different inlets and outlets for water. The split units, they don't have 4 inlets and outlets for water. That's because of the fluid. The fluid through the fan coil is water. The fluid through this split unit, it's a refrigerant. It's different. Anyway, a fan coil is something that has a fan and has a coil with water, and it can be used with boilers for heating up space. Okay, so boilers, we can't have cooling power for boilers. A boiler is something that burns fuel, it generates heat, so we can't cool down anything with a boiler. So if we are using a fan coil in a heating mood, we can use boilers. Can we use boilers with chilled ceilings? What do you think? Silent. Come on, just you have 50% of possibilities
No.
of doing
Ask the
that.
question again. What did you say?
Yeah. So what
Can
do you
we
think?
not
Yes
use
or
them with chilled ceilings?
yes or no? Sorry.
No.
I'm gonna say no, we can't use them because the boiler heats
the boiler.
thing.
Yes, sure. Okay, so we are chilled. It means that we are cooling down things. If we are using the word chilled, it's because we are cooling down things. A boiler is just for heating up things. Okay, so everything that it starts with a chilled something, we can't use a boiler for that. Okay, but boilers, look at this. For heating up things, we can use radiators, we can use radiant floors, we can use fan coils, and split units. We can't use split units because indoor split unit, it's only with outdoor split units. So that's, and we can't apply these to any of that. Okay, so this is for boilers. If we are talking about a gas furnace, it's the same. So we can use this with radiators, radiant floors, and fan coils. It's the same. A gas furnace, it's a boiler that uses gas. A wood stove, it's the same. So we can use all these with a wood stove. And we can use exactly the same with a pellet stove. What are pellets? Okay, so this is the stove, and pellets are, yeah, there you go, are these these are pellets. Well, I'm sure that you can buy these anywhere because now they are very popular. Well, this is like it's wood, so we grind or smash or wood, and then we compact this wood and we create those small cylinders, and they burn very well, because if we want to burn the branches from trees or tree trunks or whatever, it's quite difficult. It's not easy. But these kind of things burn immediately. Okay, so they have a burning power which is higher than wood itself, but it's made of wood. Okay, so the raw material is wood, and then we have to grind branches and trees and whatever, and then we create those small cylinders, and this is what well, those are pellets. They are very popular now, and I think they're becoming. Why? Because it's cheap, it's wood, so it's a renewable material. We're burning fuel, yes, so but this fuel is renewable. It's not like gas. Okay, so wood and pellets are considered as renewable energies. So now we are changing, especially if we have oil boilers We are changing the old oil boilers by these pellets boilers. And we can keep on using radiant floors, radiators, or fan coils. Okay, we don't have to change the piping system. We change just the energy generation device, and we can use the rest of the system. If we have a radiant floor, we can use a radiant floor. We only have to change the boiler. So those are pellets. What else do we have here? Okay, so we have a gas furnace. Okay, let's talk about gas furnace. Well, this is not, this is it. Well, it's a terrible device that burns gas. Okay. They are very popular, but again, we don't have these in our room. We have these in the mechanical room, the basement, or somewhere, but we are not in contact with this because first we need a chimney because we have gases here. We burn gas, we generate gases, and we have to get rid of these gases. And it's something that it smells badly. It makes a lot of noise. Okay, so we are not in contact with this kind of thing. So they are usually on the basement, in a mechanical room, but they are not in our bedroom or in our living room. We don't have this kind of thing in our living room. And they run of gas. They have a gas intake, and they have a burner here. They burn gas, and then they get rid of the gases. So it's very. What's the difference between a gas boiler and an oil boiler? Well, oil boilers, I don't know, but 99% of oil boilers I have seen, they are red. Why? I don't know. But, well, we can have blue ones, but most of them are red like this. They are more complicated because they have an oil inlet, and then they have the burner. They need a chimney as well because they are generating. So don't do this, please. Okay, don't. If you have a chimney like this to get rid of gases, you have to make sure that this is a vertical pipe and it goes up to the roof. So don't do that because this is forbidden and it's completely unhealthy doing this kind of thing. Anyway, we need to get rid of those elements, and they all have something so you can apply here the pipe and you can go up. Okay, this is the burner. This is the oil intake here. And then you burn the oil here and you get rid of gases there. So is it the same as the gas furnace? They look alike, unless they are red. And I told you that most of them are red. I don't know why. But they can look alike. So there's no difference. The pellets stoves, they are something like this. This is fake, by the way. It looks like it has trunks, but it's connected to okay, so I don't think this is a good example. Yeah, but the pellet boiler, we have a tank here for pellets, and then we have the burner, and then we need a chimney as well. So all these devices are alike. They are all extremely ugly. Although with pellets, you might have pellets here or pellet furnaces here, because it looks like a fireplace, but it's not. And here they have hidden the pipe for the smoke. I'm sure that it's behind this brick wall, but we also need a. Yeah, but pellets boilers are not as ugly as gas or oil boilers. So apparently you can have one of those in your living room or in your office or whatever. And sometimes they look like fireplaces. Fake fireplaces, but anyway, it's always the same. We have a burner here and we have a pipe to get rid of the gases that we are producing inside this for the combustion gases. So now we know a little bit about all these elements. Okay, so we have seen boilers, wood, pellet, gas. What about the ground source heat pump? Okay, the ground source heat pump, what do you think? Can we use ground source heat pumps with fan coils, radiators, radiant floors? Can we use a ground source heat pump with all of this?
I think so.
What? Yes or no?
Yeah.
Uh-huh. So Franz, you say yes.
Yeah, I said yes because like I already know, or I at least know that
Yeah,
the ground
you are right.
pumps are equipped with radiator.
Mhm. Yeah, we can use ground source heat pumps with fan coils, radiant floors, and radiators. A ground source heat pump is something that runs on electricity. It's a ground source because it's ground source because we are using like this. We have like buried water pipes. And this is the ground source heat pump. It's in a mechanical room on a basement. Yeah, it's not something beautiful, so we can't have these kind of heat pumps. But they are inside the building. They are not outdoors. The air to water or the split system or the split outdoor unit, it's always outdoor. But this kind of heat pumps can be indoors. Can be in mechanical rooms, usually on the basement or the first floor. But they are indoors, and then they are connected to anything that runs on water. Okay, so if those devices are using water, radiators, radiant floors, and fan coils, they are all using water. So we can connect a ground source heat pump to all of these. But the ground source heat pump runs on electricity. So that means that it can be used for heating and cooling. So we can use this for cooling. We can use chilled ceilings and chilled beams. Okay, so basically ground source heat pumps, we can use anything, any terminal unit, radiators, radiant floors, chilled beams, chilled ceilings, and fan coils. And we can provide, with all heat pumps, we can have heating and cooling, okay? So we can use chilled beams and chilled ceilings. What are chilled beams and chilled ceilings? Let's find out. Okay, chilled ceilings are things like this. This is a false ceiling, and we have water pipes running through this false ceiling, and they are between two different panels. Okay, so this is the first panel, this is the second panel, and the second panel, the panel below, they have perforations so that the air can go down. Why are we using, or why do we call it a chilled ceiling? Well, basically, it's something like that. We have water pipes placed on the ceiling. Well, we know that the heat tends to go up and the cool air tends to go down. So usually we are using radiant floors for heating up spaces because we have the hot source on the floor, and then the air, the heat air, the hot air goes up, and this is something good. But if we are going to use cold air, radiant floors, they are not good options because the cold air tends to go down. So we need the air to move. Okay, so if we want to move the air, the natural flow is from the air goes up. So if we are heating up a room, the hot source has to be below, and then the air moves up. If we want to cool down the room, the natural way is having the cold source in the ceiling, and then the cold air will go down. Okay, so that's why we have chilled ceilings and chilled beams. And we have heating floors or radiant floors. Sometimes you can find radiant floors for cooling, and you can find ceilings for heating. It's not the most effective way, but sometimes imagine, well, look at what I'm saying. If you want to use radiant floors or chilled ceilings, you need to duplicate the system. You need a system for heating, and you need another system for cooling. This is very expensive. It's very efficient from the energy point of view and from the comfort point of view, but it might be very expensive. So sometimes you can use radiant floors for heating and cooling, or you can use ceilings for heating or cooling. But usually we don't have this, okay? So we have chilled ceiling for cooling. And what's the difference between chilled ceilings and chilled beams? Well, they are basically the same, but the beam okay, there you go. So the beam, it's something that it doesn't occupy the whole ceiling. It's a specific element. Let me take you. Yeah, it's something like this. Okay, so we don't have the whole ceiling with those pipes. No, we have specific lines that are those chilled or active chilled beams. It's the same. I mean, looking at this picture, the hot air tends to go up. Here we have the cooling coil, and then it cools down that air, and then the air goes down naturally. So it's a very effective way to cool down, because it makes the most of what the air is doing. So the air of the room, it heats up in summer, so it goes up, it passes through this cooling coil, then it cools down, and then it goes down. Okay, so it's a very effective way because you don't need to move the air with a mechanical ventilation. You don't need a fan to move the air. So it's the natural flow of the air. The hot air tends to heat up and then passes through a cooling coil and then goes down. So I like this system, and in most of high performance buildings, they have this kind of chilled beams. And I think it's more effective than the chilled ceiling, because the chilled ceiling, it's the same, but here everything is concentrated on this element. In chilled ceilings, we have this cooling coil throughout and I think it's more expensive than this one and less effective. So I like chilled beams. Okay, so that's it. But they are using cold water. So if they are using cold water, we need an energy production system that runs on electricity. So air-to-water heat pumps can work with this as well, and ground source heat pumps can work with this. Okay, so when we have a heat pump, we can use all these elements for heating and cooling. What is a chiller? A chiller is it's a heat pump, but it's only working in the cooling mode. Okay, so we use chillers only for cool down, especially water. So can we apply chillers to fan coils, chilled ceilings, chilled beams? Yeah, we can, but only for cooling down, not for heating up elements. And what is a refrigeration tower? Well, this is more complicated, and I'm not going to explain today what the refrigeration tower is. Tower. Okay, those are refrigeration towers. We have some of these in the TDS center on the roof. And what is a chiller? those are chillers that are used on the basement. So they are blue, and well, they are devices like this, but they are chillers on the roof of the buildings. Yeah, so this is a chiller. This is on the roof, and sometimes, again, it's very difficult to tell what a chiller is and what a refrigeration tower is. They are like, okay, so it's inside it works in a different way, but outside they are boxes with pipes or ducts here, and with these grills and coils. So sometimes chillers and refrigeration towers, they are very difficult to tell. But I think refrigeration towers are difficult. They are very effective. They have a lot of issues. So they are very effective from the energy point of view, but they have a lot of issues about diseases, and so we have to be very careful with these kind of towers. So there are these kind of towers in every single building because they are very cheap and very effective, but we have to, the maintenance of these towers have to be, well, every month or every other month, you have to go there to disinfect everything, clean up everything, because they can have a lot of bacteria and viruses. And I mean, if there is a good maintenance, there is no risk. But if the maintenance is not good enough, we can have some risks with this kind of refrigeration tower. Anyway, we will talk about this later. So as you can see, it's complicated because sometimes, well, it's complicated, but on the other hand, it's very simple because most of the devices here, most of the terminal units, we can use them with many of those energy production devices. But we need to know that, okay? We need to know first what we want, and finally, we need to select the best system when it comes to energy efficiency, when it comes to budget, because if we have an unlimited budget, we can design the most effective system on Earth. But sometimes we have to duplicate things. We have to duplicate the heating production, the cooling production, or the heating terminal unit, or the cooling terminal unit. So to achieve the most efficient system, probably we'll have to duplicate things. And finally, we have energy efficiency, we have the budget considerations or the budget constraints, and then we have time. Again, we can design this, but if we have to submit a project in a couple of months, well, sometimes we have to make quick decisions that might be not the best ones. Sometimes we are under pressure and we have to make decisions, and we have a lot of pressure. As an architect, we have pressures from the client, from the constructor. Everybody's putting pressure on us, and sometimes say, okay, let's do what I have done before, that it worked, and I'm still here. They didn't sue me, and I'm not in jail, so it worked, so I'm doing the same. And sometimes you don't want to run risks, because running risks is complicated. Okay, so this is, and then we have ventilation devices. We will talk about these ventilation devices next on Thursday, because we can connect some of these energy production, especially to air handling units. Okay, so what's next? I want to solve this, but I think we are running out of time, and I will solve these kind of things on Thursday. And the goal of that lesson is something like that. Okay, so we are complicating things, and you should be able to design this kind of schematics. We have chillers, we have boilers, we have buffer tanks, we have expansion tanks, we have circulating pumps. Those are fan coils. those are air handling units, those are solar thermal collectors. Okay, so if we are designing a an efficient building, we will have to combine all these devices or all these systems. And sometimes it's complicated because there are a lot of pipes connecting things. There are a lot of ducts getting rid of smoke or supplying fresh air to different rooms. There are pipes for showers. And okay, so there I will show you how to create those schematics, because basically here we have everything. Okay, so we have all the elements involved in the heating and cooling systems, and then we have to connect those elements. So if this is a boiler, we can connect the boiler to the radiant floor. If this is the outdoor split unit, we have to connect the outdoor split unit to the multi-split indoor unit. If there's a buffer tank, and this buffer tank provides hot water to the shower, okay, but we need to heat up the water here, so probably we will have to use this boiler to heat up the water on this water tank. And it can become more and more complicated. And there are a lot of arrows, a lot of pipes, a lot of ducts, air ducts. But over the next few weeks, I will show you how to prepare those schematics from this one, which is very simple because we only have a thermal collector, a buffer tank, and the shower here, or the bathtub, or whatever. And this is more complicated, and I think this is the most complicated of all of them. But everything starts here. Okay, so if you have a device, you need to know if this is an energy production device or a terminal unit. And then you need to know how it works and what kind of devices we can connect, what terminal unit we can connect to to energy production devices. And if you know this, then you know everything about systems. So we are on our way to understand all these things. If you don't, I mean, this is very complicated, and if you look at something like that, you get lost. I don't understand everything. But if you split things, or you say, okay, what is this? This is the air handling unit. We have a heating coil and we have a cooling coil. Okay, so we need a heating coil. So how can we generate heat? In this case, with a heat pump. Okay, great. And how can we generate cool? In this case, with a chiller. Okay, so we have a heat pump. I connect this to the heating coil. We have a chiller. I connect this to the cooling coil. Perfect. So if you understand what each element is and how it works, connecting things, it's quite easy. Okay, so where were we here? I'm going to publish all these. So you have this lesson on heating systems, and then you have this quiz 3. There are only 5 questions. Okay, so it's quite easy, and most of these questions, we have solved these questions on today's lesson. So I think you can complete the quiz immediately. And if you need help, you can always watch the videos on heating systems here. Any questions?
Fernando, I think we should all sing happy birthday to Melissa. 1, 2, 3.
Happy birthday, Melissa.
Happy
Birthday to Melissa.
Melissa.
Happy birthday, dear Melissa. Happy birthday to you.
That was beautiful, Mom.
Jesus